I'm going to emphasize the transformation rules that we did with the linear functions. And you're going to see that all the same rules apply no matter what function or parent function you're dealing with. Right, so if you look at this as far as the absolute value goes, the parent function graph, y equals absolute value of x, if x is a positive number, y is the same positive number. So that graph is just going to go up at a 45-degree angle, okay, starting from the origin. If x is a negative number, bless you, if x is a negative number, the y is just the positive of that. So once again, it's going to go up in a 45-degree direction. It's going to be this V shape. Okay, so this is what the parent graph looks like for absolute value. Right, so all the transformation rules that apply to this particular V-shaped graph. Okay, now, again, just as a reminder, the lowest point of this graph, or that is called the vertex. It's the point where it starts to go from decreasing to increasing. Okay, let's go through and talk about what the different transformation rules are. Okay, first, we have this value being added or subtracted outside the function itself. Does anybody recall what kind of shifting occurs from that? If you add or subtract something outside the function, it is a vertical shift. Okay, if it's positive, it goes up. If it's negative, it goes down. So if k is a positive value, then it's going to shift up. If k is a negative value, it shifts down. Okay, then we have another transformation that occurs inside our function. So again, the vertical shift is outside the function. When you embed something within the parent function itself, the shift is horizontal. And again, the easiest way, the way that I've always taught this, is the shift occurs, whatever value of x gives you a 0 inside. Okay, so if you can get a value of 0 inside that absolute value when x is 5, then the shift is a plus 5 to the right. If you can get a value of 0 inside that absolute value expression by plugging in negative 5, then your shift, the horizontal shift, is to the left 5. Again, we'll go through an example of this here in just a moment. Okay, and then the final transformation rules that apply to this have to do with the number, the multiplier out front. Okay, and there's two different rules for this. The first rule is a rule of reflection. Okay, and the rule for that is if a is a positive number, then there's no reflection. And if a is a negative number, there's a vertical reflection. And this is also called reflection across the x-axis. Okay, so what that means is if in this particular case, if a is a negative number, then this whole V shape gets reflected across the x-axis, or gets vertically reflected, and so it would then point down. Okay, there's another rule that's met by this a value, and that is shrink or stretch. Okay, again, if you're looking at, in terms of the absolute value, the magnitude of a, if a is a value greater than 1, then the graph is going to stretch, which means the graph gets steeper. And if the absolute value of a is less than 1, meaning it's a fraction that's smaller than 1, then you're going to get a graph that shrinks from the parent graph, which means it's a flatter graph. Okay, so these are the transformation rules. They apply to every function, including the absolute value functions that we're going to look at here. Okay, so let's say we take an example of this. Right, if we take the following equation, y is equal to 3 times the absolute value of x plus 2 all minus 1. And if I want you to sketch this graph, right? Again, everything is based on this parent graph. You don't need to draw this in. I'm simply going to put it here as a reference. But let's take a look at how these transformations occur. Right? The first thing is, and the point that we'll begin with as a reference will almost always be the origin. So we're going to take this point at the origin, and that's what we're going to start shifting with these transformations. Okay? We're going to use the transformation or the translations first, the vertical and horizontal shifting, and then we'll go through and look at the size and shape changes that occur. Okay, so the first one is vertical shift. What is our vertical shift according to this function? Minus 1 is down 1. So we're going to take this point, we're going to move it down 1. And then what is the horizontal shift that occurs? What value of x would give you a 0 inside here? A value of negative 2, right? So our shift is to the left 2. And so that's going to be our point. So this vertex gets moved to this point. Is this graph going to open up or down? So you're looking here. So is there a reflection at all? No reflection, so it's going to continue to open up. Right? And is there going to be a shrinking or stretching effect? The absolute value of this multiplier out front is greater than 1, so it's going to be stretched, or it's going to be steeper. And in actuality, the stretch of an absolute value graph is very consistent. It's A as a slope. So our slope right here is 3 over 1, so we're going to go up 1, 2, 3, over 1, and you go over 1 in each direction. So up 1, 2, 3, over 1 in the other direction, and that gives you the sketch of your graph. And so you can be very precise with these transformation rules when dealing with absolute values.